Hello viewers, welcome to the session on evaluation technique for classification model in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Firstly, let us understand what is this confusion matrix. It can be clearly understood when we consider a binary classification where the output variable can have only two values, either 0 or 1. So the simplest is 2 by 2 matrix. So for n classification model, it will be a n by n matrix. Let's scale it down and understand it in a 2 by 2 matrix. So let us suppose for a binary classification, the predicted values can be 1 or 0. So 1 is represented as positive or 0 is represented as negative. So whenever our predicted value is positive and in actual also it is positive, then we call it as true positive. And when our predicted value is positive but in actual it is negative, then it is known as false positive. When our predicted value is negative but in actual it is positive, then we call it as false negative. And moreover, when we have predicted negative and in actual also it is negative, then we call it as true negative. So whenever we want to find the accuracy of the good predictions, means correct predictions, then it is true positive but true negative. That means we have predicted positive, it is also positive, and we have predicted negative and in actual also it is negative. So in confusion matrix, we will be dealing with accuracy, precision, recall and F1 score. Let's understand them with an example. Let us suppose we are given an actual values list and also a predicted value list. It is an alternative dog, cat, not alternative, means a list of containing dog and cat, and the prediction whether we have predicted it correct or wrong. We have here the predicted values. In total there are 20 values, and let's construct the confusion matrix for the same. In predicted values, the number of cats we have predicted as cat, and in actual also they were cat. In the actual values they are 6 in total. Similarly, we have predicted that it's a not cat, but in actual it is a cat. We are having such that one value. And also we have predicted that it's a cat, but in actual it's a dog. So such that we are having as 2 value, and it is a type 1 error. And in actual we have predicted it as negative, and in actual also it is a negative, which means we have predicted that the given image is a dog, and in actual also it is a dog. We are having such values as 11 in this list. So let's now look into the term accuracy. Accuracy simply measures how often the classifier makes the correct prediction. Accuracy is a valid choice of evaluation for classification problems which are well balanced and not skewed, or there is no class imbalance. So whenever there is no class imbalance, we go to find the accuracy, and it is simply true positive plus true negative whole divided by all these values. So the diagonal elements in the numerator and all the 4 values, summation of them as the total predictions in the denominator, and we can find the accuracy. So here the true positive are 6 and true negative were 11, 6 plus 11, and we have calculated it as 85%. Similarly, now let's look at precision. It is a measure of correctness that is achieved in true prediction. That is, it tells us how many predictions are actually positive out of the total positive predicted. So out of total positive predicted, how many were actually positive? This is known as prediction and precision. And precision is a useful metric in case where false positive is a higher concern than the false negative. Let's take an example. Let us suppose in spam detection, we need to focus on precision, because suppose mail is not a spam but the model predicted it as a spam. So we have to be very careful here. We always try to reduce the false positive. So how is precision calculated? It is calculated as true positive by true positive plus false positive. Similarly, how many actually were positive out of the total predicted positive? So we have predicted, in total we have predicted 8 as positive, but in actually there were only 6 positive. So that is what we have done in the precision. Similarly, in recall value, recall is a measure of actual observation which are predicted correctly. That is, how many observations of the positive class are actually predicted as positive. It is also known as sensitivity. And recall is a valid choice of evaluation metric when we want to capture as many positives as possible. Let us take an example whether a person is having a cancer or not. In such a cases, if we have predicted that he is suffering from a actually he is suffering from a cancer, but the model predicted that it is not suffering from cancer, then it is a huge concern. So recall comes into a play here. So for calculating the recall, it is given as true positive whole divided by true positive plus false negative, means the actually positive out of the total actual positive. Earlier it was total predicted positive. So after this we have calculated a recall also, and once after understanding precision and recall, F1 score will be a cakewalk for us. F1 score is the harmonic mean of recall and precision. We have taken the harmonic mean because harmonic mean punishes the extreme values more in compared to the arithmetic mean, and F1 score should be usually higher, close to 1, then our prediction is said to be a good prediction. And you might be having this confusion when to use accuracy, recall, precision or F1 score. Let me narrow it down. So accuracy is used when the true positive and true negatives are more important, means accuracy is a better metric for the balanced data. And whenever our false positive is much more important, we use precision at that time. Similarly, whenever false negative is much more important, then we use recall. Remember the example? Just recap it. Yeah. And after that, F1 score is used when the false negative and false positive are important, and F1 score is a better metric for imbalanced data. Okay, after understanding all these confusion matrix terms, let's move into ROC and area under ROC curve. The ROC curve is a plot of false positive rate versus the true positive rate, and whenever you can see the various performance of the ROC curve. If the ROC curve is moving near to this line, then it is said to be a low performance model, and it is a medium performance model, and it is a high performance model. And area under ROC is nothing but the area under this. Here you can see it is nearest to 1. Whenever the area under ROC curve is near to 1, then our prediction is pretty much good. So here the prediction is very less because it is giving almost 75% of the area, and here the least because it is close to about 50% of the data. I hope you are now clear with the terms. Now it's time, and also the higher the value of area under the curve, the best is the model, the caption, which you need to remember every time. And also now it's time for your favorite hands-on session on classification evaluation techniques in Python. So in this hands-on session, I will be evaluating all the evaluation metrics of classification model on the logistic regression, and moreover I want you to try the same in all other classifiers such as KNN, support vector classifier, decision tree classifier and random forest classifier to get an edge over the topic. So firstly, what we have discussed is, let me execute this chunk of code first for the logistic regression. If you haven't watched the same, I request you to go back and watch that playlist first. 1 second. There is an issue with the execution, I guess. Yeah, this is this logistic regression code. Let me execute this first. Yeah, it has been executed successfully. Now let's try to show the confusion matrix. For using the confusion matrix and all its features from the sklearn library, we have to use matrix class, and we have to matrix model, and we have to use the respective classes. For confusion matrix, we have to use confusion matrix. For accuracy score, we have to use accuracy score class, and for precision, we have precision score class. For recall, we have recall score class. And for finding the confusion matrix or printing the accuracy score, we first need to create an object of that particular class, and we have to pass the arguments, which is nothing but our tested actual value, which is nothing but y test, and predicted value as y predicted. Now let me first execute the chunk of code for the confusion matrix so that you can get a clear idea of over it. Yeah, see here you can see, and moreover here 65 plus 20 is 85. 8 plus 3, 11 are wrong prediction. So our correct prediction were 89. So our accuracy score should also display 89. Let me execute this chunk of code. See, it has shown as 0.89, which is running pretty good. And now let's check the precision score for the same. See, it has come out to 88.8%, and also the recall score. Let me just rename here. Yeah, and for recall score you can see it has come out to be 75%. And now if you want to see all these features into one, we have a classification report class where we can see all this precision, recall and F1 score into a single matrix. See, here you can see for each of these subclasses, which is nothing but 0 classification, and for 1 classification the precision, recall and F1 score, and also the average of these both are weighted here, and moreover you can find the accuracy right here, and it shows the total number of records in that model. And after that, for ROC curve, we have already seen how to use the ROC curve. Let me tell you what we are going to do for implementation of ROC curve. From the sklearn library, we have matrix class, and we have to import ROC curve class, and in the ROC curve class we have to pass on the actual value and predicted value, and I have created the title of the plot as ROC curve and the X label as false positive rate, true positive rate, and moreover this is going to give us 3 values, which is false positive rate for each of the actual data and true positive rate, and moreover threshold is a point. Let me execute this chunk of code so that you can understand what is the threshold. So threshold is that point from where the curve gets changed. Here you can see the same ROC curve plot, and this is the point threshold where we are getting. And in order to print area under the curve, we have ROC area under curve score, and we have to pass the same y test and y predicted value. Let me print the area under the curve. It should be near to 1, and it is 0.85, which is nothing but 85.29%, which is a pretty good percentage of prediction of our model. So now you are clear with the evaluation techniques of classification also. I hope this video proved fruitful to you, and hope you have gained something extra than what you were knowing earlier. Thank you.